Good afternoon, ladies and gentlemen. My topic today is experimental studies of central tendency estimators in the form of weighted and preferential medians. Let me briefly tell you about the plan of this presentation. Firstly, I'd like to tell a little bit about estimates of the central tendency, where we use them and what problems we face when working with standard estimates. Then I'm going to introduce you the estimate we propose and how to calculate it. And then we will move on to the presenting and analyzing results of experimental investigations of the proposed estimate and weighted median estimate. An estimate of the central tendency is a single number used as a representative of a certain given set of values, with the three most common measures being the mean, median, and mode. Such estimates play a vital role in data analysis. One of the fundamental examples can be regression analysis, where the parameters of the regression, the slope and y-intercept in linear regression, are calculated using the estimates of central tendency. The accurate estimate determination crucially affects the adequacy of the regression model and the conclusions obtained on its basis. The classic estimators have their own advantages and limitations, allowing each of them to occupy its own niche in the data processing. The main challenge here that we face is that the input data for processing are often heteroscedastic, not normally distributed, or contain outliers. In such circumstances, using standard non-robust estimators leads to the biased or skewed results. One of the solutions is to use weighted version of the robust median estimate, which is known to be one of the most robust estimates. So from a statistical perspective, the weighted median is a 50% weighted percentile. Unlike the regular median, it gives more importance to certain data points based on their assigned weights. In general, to calculate it, we sort the data, multiply each value by its weight, and find the value where the cumulative sum of weights reach 50% of the total weight. Though being highly robust, the weighted median is not free from some shortcomings, such as subjective weights assignment and the lack of an analytical formula to estimate its uncertainty. To overcome these difficulties, we propose an alternative estimate called preferential median, determined by the interval fusion with preference aggregation method. Let me explain how it works in detail. In general case, we consider a value of some quantity along with its uncertainty as an interval on the real line and set of initial intervals as input data for the IFPA method. By interval data fusion, we understand the procedure of determination of a resulting interval, which is consistent with maximal number of initial intervals and contains a point, preferential median, that can be considered as a valid representative of all initial intervals with a corresponding uncertainty. So the key idea of the method is to represent each interval by a ranking of discrete values belonging to the interval. In other words, we transform interval data in ratio scale to rankings in ordinal scale and then transform it back, which allows to get the accurate and robust result. The method contains four main stages, and let me briefly explain them one by one. We start with forming a range of actual values by combining the initial intervals and dividing the range into n subsequent subintervals of length h to get the discrete values a in accordance with the following rules. Then, we represent each initial interval by a ranking of discrete values. If the value belongs to the particular interval, it means that this value is more preferable than another value that does not belong to the interval. If they both belong to the interval, they are considered to be tolerant. Now we have a preference profile for the set of initial interval. Next step is determining the tournament matrix, and we do this in accordance with the following rules. In each pair of values A, if AI is more preferable than AG, J, it has 2 points, and 0 point in the opposite case. If they are tolerant, AI has 1 point. So, by calculating the number of points for each pair of discrete values for each ranking, we get the tournament matrix containing the sums of its rows. And finally, to determine a single consensus ranking which represents the best compromise between the initial rankings, we apply one of the voting rules. In this research, we used Borda rule. So, the best alternative in the determined consensus ranking is a preferential median with a corresponding uncertainty. To evaluate the performance of the proposed estimate, we experimentally investigated the IFPA method on synthetic pseudo-random interval data. During the experiments, 100 interval data sets were generated, and for each set, both preferential median and weighted median estimates were calculated. The parameters of the experiments are presented on the slide. Based on the experimental results, the robustness, accuracy, and confidence of each of the estimator under study were assessed. As a measure of accuracy and robustness, the absolute deviation of the estimator from nominal value was used. And since there is no simple analytical formula for median type estimators, the uncertainty of each estimator was calculated using bootstrapping and repeating resampling 1000 times for each dataset. As a measure of confidence, they were used the probability estimates of that the deviation psi does not exceed a certain critical fixed value. This slide demonstrates the curves of deviation and uncertainty obtained for preferential median and weighted median, where the values are put in ascending order to improve the visual clarity. The robustness of the estimator is demonstrated by the width of the petal formed by the curves for the normal and uniform distributions. The narrower the petal, the more robust the method is. As we can see, for both deviation and uncertainty, preferential median in general shows the same or even higher robustness in comparison to weighted median, which is known to be one of the most robust estimators. The accuracy of the estimator is characterized by the average distance between curves and the x-axis. As can be noticed, the obtained results indicate a higher, approximately 20% higher accuracy of the preferential median compared to the weighted median for both normal and uniform distributions. The critical values for deviation and uncertainty for two estimators at three given confidence probabilities are given in tables on this slide. For almost all probabilities, the smallest critical deviations and uncertainties were obtained using the preferential median. In conclusion, I want to say that the results of the experiments show that the proposed preferential median estimate seems quite promising. It provides high accuracy and equal or even higher robustness in comparison with one of the most robust estimates, weighted median. Confidence indicators also demonstrate the superiority of preferential median to weighted median. In addition, preferential median does not require assigning any weights to the sample values and allows to evaluate its uncertainty without time-consuming bootstrapping procedure. Thus, the preferential median can be recommended to be applied in data processing tasks, including regression analysis. The next step of our research will be to estimate the sensitivity of preferential median and weighted median to outliers. Thank you very much for your attention.